Picking up in lesson 8.2, where we left off. We are working with more ellipses today. I don't know if any of you guys have started the homework a little bit, but there's some doable stuff in there. I had some people working out during homeroom this morning, and they were making some progress. So, needless to say, I do expect you guys to bring your ellipse questions on Monday, though. Okay, try the homework over the weekend, and we'll talk Monday and work to get what questions figured out we need to. My plan today, as I said, is example 4 and 5A. So, yesterday we ended up with example 3, and example 3, they said, okay, here's this information, write an equation. Now it's, here's this equation, find this information. So in example 4, we're going to be finding the center, vertices, and foci for this equation. As always, you guys have the chart up above, yes? So obviously, I keep repeating, that chart is, whoops, important information. What are your thoughts about this? What information can you gather from staring at that equation and with your chart helping you along the way, hopefully? Okay, you got something, Jake?
Well, I have a question. Didn't we just put this into our calculator or something similar to that, or no? To get the graph?
Well,
To get like our center?
to put it into the calculator, you'd have to solve it for y.
Okay.
Which is a lot more work than the fact that, in my opinion, the center is just staring at me. Okay? I wasn't processing if you gave it right or wrong, but the point is, does stand H and K. Once we get it figured out, H and K are right there in front of us. And regardless of whether this is left column or right column, H is always with which variable? X. And K is always with the Y. It doesn't matter if it's left or right column, that's always the case. So yes, the center is staring there at us. The center is going to be what? -2 and 5. Because X plus 2 and Y minus 5. I'll write that down in a moment. I want to get somewhere else first before I write that down. Okay. Okay. Okay, so we need to talk about A and B. We have the 9 and the 49 there, yes? And so the square roots of those are going to be my A value and B value. Which is which? Okay, there's the key fact. 7, so the square root of 49 is 7, and 7 is my A value because in an ellipse, the A value is always larger. So, with that said, which column is this? Right. My A squared, my larger value there is under Y, and so this is actually a right column problem. Okay? That's what I need you to recognize there, that this is a right column problem. A always has to be larger, which means 49 is my A squared value, which then means A is 7. B is the smaller one, and so that means B squared is 9, and if B squared is 9, then B is 3. Now, I'm going to go ahead and write down our format over here. The fact that this is a right column. And I'm going to say it's a right column, and I'm going to put the comment because A squared is larger. Okay, A squared is always larger. So that means this is really Y minus K squared over A squared plus X minus H squared over b squared equals 1. If you wanted to and needed to, you could rewrite your given equation, couldn't you? Okay, I'm not going to say you have to be honest, I'm not going to. But if it's confusing you, the fact that I'm not, then please, flip yours around. Okay, so A is 7 because A has to be larger. That means this is a right column. Let's see, the center was already identified. Please remember your center is HK. Excuse me. And so H always comes from the X value. Since it's X plus 2, it's negative 2. K always is associated with the Y coordinate. Since it's Y minus 5, we're going to use 5. So my center is negative 2, 5. And as we mentioned, those are H and K. This problem says nothing about graphing. And to be honest, we can continue and we don't have to do graphing at all. However, I also feel like it would be a good one to graph to help you experience how this all puts together. So, before I move on to find vertices and foci, I want to graph this. Okay, because I want to make sure we really truly understand the connections here. And I'm not quite sure we have it all together. So, I'm going to graph this over to the left. Excuse me. What's the first thing you can graph?
Center.
The center at negative 2, 5. So, left 2. Up 5. So there's my center at negative 2, 5. Now, how do I know how to graph the next part? Now I don't even know which next part I guess I should say. I guess how should we get to the vertices, the ends of the major axis? Does that make sense what I'm asking? We could use the formula, but I don't want to use the formula. I just want to count on here. What do I have to count? Well, first of all, where's my major axis going to go? Is my major axis going to be horizontal or vertical? Vertical, because this is a right column problem, yes? And here's the other thing. My larger number indicates the major axis, and my larger value here is under Y. Y values go up and down. A equals 7. Because A is 7, that tells me how far that I have to count up and down to get to my vertices. So from my center. So your A value, because it's under the Y coordinate, tells you how far to go up and down. Okay, and this is why I wanted to graph this, because I feel like this is a connection that hasn't been well made yet. But the idea here is that because A is 7 and A is under Y, in the Y direction, I'm going to count up 7 and down 7. So up 7 and down 7. And when I went up 7, realize that is an A value. And when I go down 7, that is an A value. So right there, from my center, I go up 7 and down 7. I just realized, based on what my morning class told me, I might be in a glare for you virtuals. So let me try and center this a little bit better and maybe make that a little bit better for you guys. Please tell me if there's something you can't see that I need to adjust. Okay. So A, because it was under Y, told me how far to go up and down. How do I know how far left and right to go? Good guess, the B value. Okay, the B value takes you to the end of your minor axis. Notice in this problem, my B of 3 comes from being under the X. Which way do X's run? X's run left and right. So that means I'm going to count 3 left and 3 right. And so by counting 3 left and 3 right, I used my B values. That gives me my other points on my ellipse. And then you can attempt to connect these points, right? Okay, I think I have a football going. We'll go with it. Okay, so as I said, my point in graphing is I want you to make the connection about A and B. Okay? A counts you out the major axis, B counts you out the minor axis, both from the center. In order to know which one is which, look at which variable it's under. X's always go left and right, Y's always go up and down. Now, could you tell me your vertices by looking at this graph? Where are vertices? They're on the graph. What? Okay, vertices are the ends of the major axis. Major axis was when I counted 7 up and 7 down. So you can look at your graph and figure out what those vertices are. Now, on the flip side, did we even have to do a graph here? No. And because we still have to find foci also, right? Foci aren't on here yet. But, so my point is, you could do a graph here. And again, it's not that we had to do the graph. I'm not saying that at all, but I just wanted to kind of make some connections. But let's find another way to do vertices as well. What's your handy dandy chart say about vertices? Okay, my vertices are H, comma, K plus or minus A. And Sadie picked that because we are working in the right column. Do we know H, K, and A? We do. Which, as my point is, we didn't have to draw a picture because we know H, K, and A. And it would have been quicker this way, but making connections. So let's see. H is -2, comma, K is 5, plus or minus A, which is 7. I am going to say that is not what I want your answers to look like. Because can we do 5 plus or minus 7? Yes. So one answer is going to be -2, comma, 12, because 5 plus 7 is 12. My other answer is going to be -2, comma, -2, because 5 minus 7 is -2. Those are your vertices. When you can do that basic math, 5 plus 7, 5 minus 7, please go that step and do it. Do these ordered pairs match up with your graph? Yeah. -2, -2, -2, 12 is slightly off my screen right now, but they match up. Okay. What's the other piece of information I have to have? Foci. Okay, time out. What's my formula for foci? What's the chart say about foci? H, comma, K, plus or minus C. And you guys realize I'm not doing magic to come up with these formulas, right? I'm not, I promise. You look at the chart, it's right there on the chart. We're in right column, the chart says foci, H, comma, K, plus or minus C. Because some of you will think I'm doing magic, and which is why I'm trying to point out that I'm not. Okay, what's the problem? We don't have C. Okay, Pythagorean relationship is what she's trying to say. I can't say it without laughing now. Pythagorean relationship. Anytime you know 2 out of the 3 of ABC, we can use the Pythagorean relationship. So, Pythagorean relationship, for an ellipse is C squared equals A squared minus B squared. And that is also not magic, that's in your chart. Okay, C squared is what I'm trying to find. A squared, so A 7 squared minus B squared, so minus 3 squared. C squared equals 49 minus 9. C squared equals 40. If C squared is 40, then C is square root of 40.
I was trying to think what goes on in it.
Okay, so valid point. I believe, off the top of my head, I want to say this book does not simplify the radicals at this exact moment. So I was just leaving it as square root of 40. However, 2 square root of 10 would be the simplified version because 40 is 4 times 10, square root of 4 is 2, so 2 square root of 10. For this, the C value itself is just square root of 40. Because anytime you plug C into a formula, the plus and minus is already going to be there. Speaking of which, so foci, H, what was H? Negative 2, K, 5, plus or minus, and I just wrote square root of 40. If you wrote 2 square root of 10, that's fine. And what am I going to say about this one? You get to leave it. Okay? If you were just being asked to tell me what are the foci, we don't have to graph them, you're just being asked to tell me what are the foci, and there's a radical involved, you can leave it. Same thing with the vertices. If there's a radical involved, you can leave it. You don't have to necessarily work it out. Okay? Now, if you needed to graph this, could you do the math? Or could your calculator do the math for you? Yes. If you needed to graph it, your calculator could do the math. But, I mean, if we needed to graph it, my calculator would tell me negative 2, comma 11.32, and negative 2, comma negative 1.32. Again, we're just being asked what the foci are. I would leave it in the radical form. Okay, we got it? You got it, Jake? I've got Garrett with me at the moment, but not Jake at the moment.
A few minutes ago, I was struggling a little bit.
Well, get up, take a walk. I agree.
Yeah, that was a good idea.
Okay, I'm ready for 5A when you guys are. Now, on this backside, there's actually 5A, B, and C. We are only doing 5A. These are time-consuming problems, I'll be honest. Okay? So, we are only doing 5A, and I say that because I'm going to kind of run down into 5B most likely. So, okay? Show that the following equations are that of ellipses. So notice it says we need to show that this is an ellipse. And then we're going to find vertices, foci, and eccentricity. In order to show that this is an ellipse, we're going to have to take this equation, which is not in the form we've been working with, and we're going to have to show that this can be in standard form of an ellipse. Okay? So that is our goal here. And I'll walk you through the steps to take this equation right here. And I'm not even going to solve it for y and try and graph it. Okay, we're going to go for standard form because then we still have to find vertices, foci, and eccentricity. So we're looking to get this in that form of x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay, step 1, what I want you to do. We're going to start by grouping our x's together. Then we're going to group our y's together. And then I'm going to move any constants to the right side of the equal sign. Okay, and natural order for me, I put x's and then y's. Technically, you could put y's and x's if you prefer. So, in terms of x's, what do I have in the way of x's? Okay, so I'm going to write x squared minus 2x. I'm going to leave a gap. Then I'm going to gather my y's together. My y's, I have plus 6y squared and plus 12y. I'm going to leave a gap. I'm going to put equals. Do I have any constants that need to move to the right? Yeah, there's a minus 23. So to move it across the equal sign, we're going to add 23. And so I have equals 23. Okay, x squared minus 2x, gap, plus 6y squared plus 12y, gap, equals 23. Okay, you guys know my teaching style. Why did I leave gaps?
Because something's got to go in there.
I didn't know the name of it, but I knew.
Okay, when I leave those gaps, I'm preparing that we're going to complete the square. Okay? We're going to complete the square here. So, now, before we actually complete the square, do you remember what's the form we have to be in before we complete the square?
I remember there's an
X plus.
Okay, so in order to do our completing the square steps, we have to be in that basic form of x squared plus bx, and specifically it is a 1x squared, or whatever variable we're talking about, yes? So, as we examine this real quick, x squared minus 2x, it's already 1x squared, right? So my x's are good and ready to go. Y's. Do I have a 1y squared? No. So we have to do something about that 6. I will tell you right up front, we are not dividing by 6. Because if I try and divide by 6, that's going to mess up my 1x squared over here, because I'd have to divide everybody by 6. But we're going to factor out a 6 out of any y terms. So if we factor out 6 out of y squared, we also have to factor it out of 12y. So I'm going to rewrite this line. X squared minus 2x is good. I'm leaving my gap again. Plus, and because I want that 6y squared to just be a 1y squared, I'm going to factor out a 6. And I'm just going to do it right here. So I'm going to say plus 6 times, and then in parentheses, when I factor out that 6, it's y squared plus 2y. We're still going to leave a gap, and then I'm going to end my parentheses, and then I'm still going to say equals 23. So I factored out a 6 out of my y terms. so that I now have a 1y squared. Are we okay up to that point? Okay. $1 million question here. How do we complete the square? Nice. Got some remembrance here. B over 2 quantity squared.
We had them both in the same section, and I got confused.
Okay, so with the x's, x squared minus 2x, what's my b value? Negative 2. Negative 2 divided by 2, negative 1, quantity squared, 1. What do I do with that 1? We add 1 in our gap. If we add 1 on the left side of the equation, we're going to add 1 out past the 23. Okay. Notice I left 2 gaps, right? Was that pretty obvious? Okay, so now we've got to do the same thing with our y's. Notice it's 1y squared plus 2y. So what's the current b I'm using? 2. 2 divided by 2 is 1 squared 1. So I am adding 1 here. If I add 1 on the left in the parentheses,
Yeah, what do you do with that?
on the right we're going to have to add 1 but multiply it by 6 because
I just forget it.
this 1 we added in these parentheses. Is it really just a value of 1? No, because this 1 that I added in the parentheses is being multiplied by 6. So even though I add 1 in the parentheses here, when I add it on the right, I'm really adding a 6. I wrote it as 1 times 6 for your benefit, but okay. Every time after we complete the square, the whole plan was we were setting ourselves up to factor.
I was going to say that. Right.
So we are set up to factor. We're always setting ourselves up to factor into that parentheses squared. So square root of x squared is x. Square root of 1 is 1. My middle sign is minus on the 2x, so it's minus. Or if you prefer, what multiplies to be 1 and adds to be negative 2. Negative 1, negative 1. Okay, plus, we're going to leave the 6 here, and then it's parentheses squared. Square root of y squared. Y.
I just put X down.
Square root of 1. 1. This time my middle term has a plus, so it's y plus 1. Clean up your right. 23 plus 1 plus 6. 30. Okay, guys, almost there. In standard form, we want our equation to equal 1. I have 30. How do I get 30 to become a 1?
Minus 1/9.
Divide by 30. If I divide the right by 30,
You got to divide the rest by 30.
you divide everybody by 30.
That was close.
Now, I did say we're not doing B. So you can just keep going there if you're writing as big as I am. Okay, we just got to clean it up. X minus 1 squared over 30 is still x minus 1 squared over 30. Plus, now keep in mind, when we have this in standard form, there's nothing in front of those parentheses. It works nicely here, though. Think 6 over 30. How does 6 over 30 reduce? 1 over 5. So this is going to be y plus 1 squared over 5 equals 1. By getting to standard form, I have just proven that this is an ellipse.
What if this is like 4?
Yeah, how come it just wouldn't work? What would we do?
I'll show you on Monday. It happens on 1 at homework.
Oh, yippee.
But I'm running out of time. Sorry, I'm really running out of time. We shouldn't have talked so much at the beginning of class. Okay, I'm guilty. Okay. One information. Can you tell me here?
I'm gonna look at it.
I know that.
Can you tell me H and K?
Yes.
H
Negative
comes from X, so H is
1.
1. K comes from Y, so it is negative 1. A and B.
Interesting.
A and B. A would be square root of 5.
It's your bigger value.
Oh, A would be square root of 30. I mean.
Okay, so these denominators are A squared and B squared. A squared is the bigger one. So if A squared is 30, that means A is the square root of 30. B squared is 5, so B is the square root of 5. And if you want to write it down, this also means which column are we working out of? This is a left column because A is under X. Okay. Now, if we want to go ahead, at some point, we have to find, well, no, we'll come back to that. Okay. I'm running out of time. That's all there is to it. I'm trying to. Okay, what did we have to find? Vertices. Now, we just talked, we're left column, and we are left column because A squared is larger. What's my formula for vertices if we're in the left column? H plus or minus A, comma K. Do we have all that information? Yes. H is 1 plus or minus A, which is square root of 30, comma K, which is negative 1. There's a square root involved, so I'm leaving my vertices as is. Okay. Okay. Foci. What's my formula for foci? Whoa. For foci,
H plus or minus.
H plus or minus C, comma K. My in-class students are a step ahead of me, which is fine. Noting, we don't have a C. How do we find C? Pythagorean relationship is that thingy. C squared equals A squared minus B squared. C squared is square root of 30 squared minus square root of 5 squared. Square root of 30 squared is 30 minus square root of 5 squared is 5. 30 minus 5 is 25. And C is 5.
Wow, that was so good.
Sorry, I'm going to trust that you guys can find that C value if you had to. So, H, which is 1, plus or minus 5, comma K, which is negative 1. But I'm not going to leave that, am I? Because it's a whole number. So I'm going to say 6 negative 1 and negative 4 negative 1. Because I did 1 plus 5 and got 6. And I did 1 minus 5 and got negative 4. And those are my foci.
Oh, then you do C over A, don't you?
And we have one last thing we are supposed to be finding. Eccentricity.
Yeah.
The formula, bear with me momentarily if you could. E equals C over A. So 5 over square root of 30. I don't know, I can't remember if the book lets you leave a radical in the denominator. To rationalize, I multiply by square root of 30, because I want that out of the denominator. So then I have a 5 square root of 30 over square root of 30 times square root of 30 is 30. 5 over 30 reduces to 1 over 6. So it becomes square root of 30 over 6. I know, sorry.
Oh, okay, we really wasn't that far behind.
No, you probably weren't. Okay. Get what you need for Monday. Finish the homework. I will write the homework down in case anyone needs it.
That was kind of
Sorry.
stressful. She kept talking. I was like,
Well, the stressful because I realized I was behind. Page 599.
well, I was on one step
2 through 6 evens. 7 through 10 all.
That was kind of good, though.
22 through 40 evens. 46 and 48. And again, Monday I will be doing ellipse questions.
I don't think I need help this time. I think we'll be good.
Even the part you slept through.
Yeah, because I knew that already. Have a good day, Miss Sergeant.
Thank you, you too.
Thank you.